Hello, I'm Jerome, and today I'll be explaining differentiation and integration using the inverse trig function. I will start off with the sign function. Y equals sine of x, and x exists from negative power 2 to power 2 will go as shown. Now, once you do the arc sine, which is the inverse sine from x exists from -1 to 1 on a closed interval, is going to be a slightly skinnier slope of a line compared to the much wider slope of sine of x, which leads to this triangle of hypotenuse 1, opposite side x, and an angle of y. Using this triangle, we know sine y equals x and cosine y dy dx equals 1. Previously, we already know from trigonometry, sine equals opposite over hypotenuse and cosine equals adjacent over hypotenuse. The sine of y will be x over 1 and cosine of y will be square root of 1 minus x squared over 1 by the Pythagorean theorem using this triangle. Now, prior knowledge tells us that the derivative of sine x equals cosine x. So we can substitute the dx into here, which leads to the inverse being dy over dx equals 1 over cosine y. We already know from here that cosine y equals square root of 1 minus x squared. So we just substitute that in for the cosine y, and we will have 1 over square root of 1 minus x squared. So that means that the derivative of the inverse sine, also known as the arc sine, will equal to 1 over square root of 1 minus x squared. This also leads to the conclusion of the antiderivative, or the integral, of 1 over square root of 1 minus x squared dx equaling out to arc sine x plus c. This in turn makes the derivative of the arc cosine of x negative of the arc sine of x, which is -1 over the square root of 1 minus x squared. Here's the given method to find the derivative of arc tangent x. You already know that the derivative of tangent x is secant squared x, and that by the properties of trigonometric functions, secant squared x equals 1 over cosine squared x. You know that. So y equals arc tangent x. Tangent y equals x. Changing the tangent into arctangent into tangent. Secant squared y dy dx equals 1. Dy dx equals 1 over secant squared y. Substitute in the 1 over cosine squared x for the secant squared y, and you'll get cosine squared y, which equals out to 1 over 1 plus x squared. Now that you know that the derivative of the arctangent x equals 1 over 1 plus x squared, you also know that the antiderivative of dx over 1 plus x squared will give you arctangent x plus c. This, in turn, will also give you the value of the cotangent. The cotangent will be the negative of the arctangent. So arc cotangent will equal negative 1 over 1 plus x squared. For the arcsecant derivative, we will use this method. Arcsecant equals arc cosine of 1 over x times 1 over x. The derivative of arcsecant will give you negative 1 over square root of 1 minus 1 over x squared, which equals the derivative of 1 of x. This will give you square root of x squared over square root of x squared minus 1 times negative 1 over x squared, which will equal to square root of x squared over x squared times square root of x squared minus 1. The derivative of arcsecant x will finally give you 1 over x times square root of x squared minus 1 for all x values greater than 1, and it will be 1 over negative x times square root of x squared minus 1 for all x values less than negative. So this basically says that you will have to take the absolute value of x. So in the denominator, when multiplying, before you multiply it by square root of x squared minus 1, because the negative value does not exist. The finale derivative of arcsecant x will equal 1 over the absolute value of x times the square root of x squared minus 1. And that also in turn gives you the arc cosecant, which is going to be the negative of the arcsecant derivative. So derivative of arc cosecant equals negative 1 over the absolute value of x times the square root of x squared minus 1. This in turn leads to the antiderivative of dx over the absolute value of x times square root of x squared minus 1 equals the arc cosine of x plus c. For our first example, we will use the number 39 in section 7.7, which is the integral from 0 to 1 of dx over 1 plus x squared. This also equals the integral from 0 to 1 of the quantity of 1 plus x squared to the negative 1 power dx. Now, I will take the integral, and it will be the integral of the inside of 1 plus x squared is 2x. So it is 2x times the natural log of the absolute value of 1 plus x squared from 0 to 1. Now you plug in the values of 1 and 0. It will be 2 times 1 times natural log of the absolute value of 1 plus 1 squared plus 2 times 0 times the natural log of the absolute value of 1 plus 0 squared. And since you already see is multiplied by 0, the right side will be cancelled out and equal to 0. And all that will be left is 2 to the times the natural log of the absolute value of 2. My name is Jerome, and this has been my explanation.